And in every collection, we have two flavors. Like, so one is a mutable version, and second one is a immutable flavor package or the class. So mutable ones are available in Scala.collection.mutable, and immutable ones are available in Scala.collection.immutable collection package. And list and set, all the operations are also look pretty similar. Only thing is set will have the unique values, and lists may have duplicates as well. Okay, and coming to the map, same as your Java collections maps here as well. These are key value pairs, and any value for a given key is retrieved based on the key, and keys are unique in the map, but values need not be unique. Okay, so for the same key, so multiple values can also be get assigned, or the value can be repeated for different keys. By default, immutable maps will be created whenever you create a map. And for creation of a map, it's a simple, same like, so we were creating the lists, val list equal to, so list of your strings or numbers or whatever it is. And similarly, val set equal to set of, this way we were creating, right? And now val map equal to val map m1. So if you create, you have to specify your key and value separated by arrow, and any number of this key value pairs can be specified in your this thing. For example, name jux, again name, another name sp, or you can, or so country codes. Let's say if I'm taking here, the keys should be unique, right? Here, so then I should not be taking this. So age, some 35 or so. So you keep on adding values to it. You can specify these values at the time of map declaration. So anything left side on your arrow is a key, and right side is a value. Okay, so this is a single line arrow, not like 2 lines arrow where we were using this for a function definition, right? So f colon int arrow int. So this was for denoting a function. But if you specify this single line arrow, that is nothing but a key value pairs are separated inside a map. And for example here, so I have defined the state codes and their full forms. So all the different state codes will be keys, and their descriptions will be the values. And when I create the collection by default, so val states equal to map of so and so value. So if you see, by default it's creating you an immutable map. But if you want a mutable one where you can add, so the same formula, same format, declare this as a var and select this complete package, Scala dot collection mutable dot map. This creates the mutable version of it. Okay. So in this, so when you declare this immutable one, so you can just keep on referring those values. That's it. If you need the ability to keep on adding a new key value pairs, so then obviously you need to declare that as a var and a mutable version of it. Then, so how did we see that? So we saw that for list or set, addition of elements, new elements just by element plus equal to your new element, or the list equal to. So the right side element will get added to your list or set. And the same way here for maps also, your key value pairs can be added by just plus equal to. If you want to remove, minus equal to. And if you want to add another list, plus plus, another map. Okay, sorry. And if you want to look through them, so we have on a map, we have a method called keys, which retrieves all the keys as a list. So if you observe here, I have declared a map with the keys, all keys are left side comma separated, and their values, the color name, and their color code. And colors.keys will return all the keys as a list. That returns all the keys as a list, red, azure, and Peru. And on lists, we have a method called Foreach. As we have seen here in the list, Foreach is to iterate through each element of this list. Okay, I think if we didn't discuss that, we'll discuss them in the next slide. So what are all the important methods on that? So for each key, for every I, so that this is an anonymous function. So I arrow means for every key that receives. So I'm just printing the key and printing the value of it using the colors of by passing the key. And this prints this way. Okay, so this way, if you need a mutable map to declare, keep on adding elements and deleting elements and iterating them through this method. And if you declare only the immutable version of it, you'll just be able to iterate through them. So mostly we'll use that map.keys.Foreach, and for every key we'll loop through the values of it. Okay, so I hope this is clear for you. Next, the tuples. So tuple is nothing but kind of structure. So till now, whatever the collections that you have seen, as we discussed even in the last session, the list, set, or map, all these are homogeneous. So once you declare a a list as a list of string, or as a set as a set of string, or a map of string comma string, then you can add elements of those data types only. You can store elements of that data types only. You cannot mix strings, integers, floats, doubles all together in one collection. So that nature you can achieve through your tuples. And tuple is, if you are coming from C language, tuple is equivalent to a struct. And if you are aware of pig scripts, tuple is exactly equivalent to your tuple in pig. But the difference between the tuple in pig and tuple in Scala, in Scala we can only add a values up to 22. So maximum of 22 elements can be added to a tuple, whereas pig does not have that limitation. That's the only difference. It's a row, or it's a set of fields, or in SQL terminology, if you want to compare this is equivalent to one row. Okay, let's say, so you have a table. So you have a table employee. So where name, age, ID, and department. So you can declare it's a record with a tuple of name as Dharmesh, and age as 30, ID as 101, and department again you can big data. That is one row, and this is another row. Okay, analytics. So your rows can be represented with the help of your tuples, or those can be read as a tuple. Okay, but how we can map them with the tuples and all those things, we'll see them in the Spark SQL. Okay, and in tuples, just give the tuple of and give any number of values. How many ever values that you specify there, how many ever fields that you specify inside it, we actually have a 22 tuple classes, like 22 or 21. So tuple of, if you specify 1, 2, just 2 strings, so this becomes like a tuple 2. And if you specify 1, 2, 3, this becomes like a tuple of 3. You can define that way as well, tuple 3 of this. And if you have 4, so you can specify tuple 4 of 1, 2, 3, 4. Or you can simply leave this numbering, and you can just use tuple and provide your fields. Yes, Nayali.
Like you said, in tuple we're going to have 22 values, one tuple. So can we have a tuple in a tuple?
Tuple.
Can we have a nested tuples over there?
Nested tuples, I don't think so.
Because in pig it's allowed. Pig we can do that. That's why.
That is tuple inside a tuple. Yeah, that is allowed in using.
Pig
correct. In pig that is allowed, but here we don't use that. This tuples are mainly meant for mapping with your table columns.
So suppose if my table has say 40 columns, then how do I define a tuple in here?
That we'll see there. I'll explain you the problem and how to solve that, and I'll show you that real-time scenario for that.
Okay, thank you.
Okay. So either you can use tuple 2, tuple 3, tuple 4, tuple 5 like that also, or you can use simply the tuple, and which we recommend, or simply just specify val t equal to a list of values that automatically gets used by that tuple. This is the more the frequent form of usage, just val t and specify any number of values that you have. And while accessing those tuple values back, we access them by the positional notation. So if I have to access 4, I can access that by t dot underscore 1. And 3 can be accessed by t dot underscore 2. And 2 can be accessed by t dot underscore 3. And 1 can be accessed by t dot underscore 4. Okay. And so that's about tuples. So the next one, the iterator. So this is a same like here in Java collections, the iterator that we have. Here in Scala, mostly we don't use this iterator because of a couple of reasons. Other alternatives are available, but still, if you want to get a iterator means it's a kind of control using which you can access element by element. Okay, so for example, I have a list 1, 2, 3, and on any collection, not just list, on lists or set or map or any collection, you will have a method called toIterator. The collection.toIterator that returns an iterator, and on iterator mainly you will have two methods. So one is iterator.hasNext, means it returns a boolean value, true or false. If the next element is present in the collection, then it returns true. So while that next element is present, as long as the next element is still existing, so I'll keep on processing those elements. So iterator.next, it retrieves that next. This while loop, while it.hasNext, println of it.next prints all the elements of this. And the simplest way, even more simpler way than this, fetching an iterator and checking for the next element and accessing that next element using these three methods. So to get the iterator, you have to call toIterator, and to check whether the next element is present or not, you have to call hasNext, and to get that value, you have to call that next. This is same as your Java, but so we have even more simple option, that is the Foreach that we have seen in the maps already. So on any collection, so almost all the collections we have Foreach method also. So it automatically loops through for every element of this collection. And that's the reason why we don't recommend the iterators. So, but using iterator for a collection is not a good idea, as we have map and for each methods and collections to iterate them. So for each we have seen, map we will see in the next slides.
Shiva, one question here.
Mm-hmm.
So the for each only works with map, or it works with your list and set as well?
So for each works with all collections.
Okay.
Okay. And so best use case of using iterator is when reading file, because putting all file data into memory is not a good idea. If it is just a collection, then go with a map and for each, that is, whereas if it is reading a file, record by record. So then that on that file, when you read that file, it might return you the collection of lines. And in that case, it might, if it is a very huge file, then you might sometimes may use this iterator as well. Otherwise, almost all the cases we go for either map or for each. And most of the scenarios we go for map only. So if you see, if we discuss the map functionality use case, then you'll find it that is even more frequently used. Okay. Yeah. So out of all these collections, the common methods that you can apply on them is the for each, map, filter, and reduce. So here, I'll explain this with the help of examples only. So I have this a list, LST, and for each, just now we discussed, like it iterates through each element of this. So list dot for each, inside for each, in all these methods, so they expect for each, map, filter, or reduce. All these four functions on collections expect another anonymous function as a parameter.
So Shiva, when for this for each collection, what is the end criteria? Like do while loop, we have an end criteria. This is the time when it terminates.
So it ends once it reaches all the elements. Once it processes.
So for example, if we have an iterative list, for example, which has been generated through, like it's been passed from somewhere, and we don't know how much is the limit. It can be 10, it can be 20. Like it extends depending on the data that we have. For example,
yep.
In a scenario we don't know what is the end of a list, then what do you do?
You don't need to do that. First thing, you don't need to worry about where that list ends. You don't need to specify how many elements you have to process. Your intention is that when you want to process a list, you want to process that completely.
Okay. So whatever at that instance is the values of the list, that would be the for each will place. So there is no end criteria to be placed.
There is no explicit end condition. It automatically ends after processing the last element of your collection. Okay. Now, so on this list dot, either for each or list dot map or list dot filter or list dot reduce. All these four functions are very, very, very important, and mostly, yeah, all are equally important, I can say. Okay. Now, so one similarity is that all these four functions expect another function as a parameter. So all these four functions expect another function as a parameter, fun, and this fun, okay, and this expects another fun, and this expects another fun. Okay, so input is a function, right? So sorry, input is a list, and you are passing a function as a parameter, and this so for each, for every element that you pass, for every element that you pass, you may produce for every X arrow, X kind of stuff. So this function, fun, so most of the times, 99% of the times, we define anonymous functions only. So this every X arrow X, meaning this X means every element present in this list. So one element at a time will be processed or passed to this, and inside the right side of it, inside this anonymous function, the right side of it, whatever you want to do, you do it. So if you simply want to print it, so do the print. But so for every element that you pass as input to this anonymous function, this produces one result. So what I am trying to conclude here is that if you pass 10 elements, you will get 10 elements as output also. And mostly this for each is so not just for processing, and you might have another extra processing for every element if you have to further process this. So we might use this. So for every element, so X that you receive, so if you want to parse that, let's say if this is a line, this is not a string, just 1, 2, 3, 4. You read a file, and every line is nothing but one string for you. And if you want to parse that line, okay, so in that case, I'll make this as line, and line dot split by. So let's assume that is by comma separated. And you collect that into another val list or something, and you can again look through that here in this, or whatever the use case. So this way, if your list is having 10 elements, this for each, and there is one more map kind of stuff, FlatMap, even that we are not discussing at this moment, but that is more or less similar to this for each. Okay, so let me put that as well here. List.flatmap. Okay, but on high level, so every element that you receive for each, you can further process on the right side of your anonymous function. If you want to print it, print it. If you want to parse it, parse it. If you want to transform and do whatever you want to do, you can do that. Okay, we will come back to this flat map in a few minutes. Next, we have map method. Map method, its characteristic is like, if you pass 10 elements, so after processing that map method, even in the result you will get 10 elements. Then in those scenarios you use the map method exactly for your input 10 elements, you will get in the output also 10 elements. The values might get changed. For example, so one simple function that I can tell you. So for every x, give me x star x. So in my input list I have 1 to 10, and in my output list this produces 1, 4, 9, like that, right? but the number of elements even in my output list is 10 only. And for a map method, your input is a list, even output is a list. And both input list and output list should have the same number of elements. The values might change, but the number of elements should be matching. The count of elements should be matching both in the input list and the output list. And in filter function, this also expects an anonymous function, and its result is also another list. Filter function can be applied on a list. Input is a list and output is also a list. But the output list, the number of elements may be less than or equal to your input list. For every x, return only if x greater than 1. Meaning, so all the input elements will be validated against this x greater than 1. So only if they are greater than 1, those elements will be copied into your output list. So here again, same like map, output is also another list. Now coming to the reduce function, this input is a list, but output is an aggregated value or just a value. Meaning just one element. You will get output as just one element. It's not a list. Output is not a list. And in this reduce function, so we'll say for every key value pair that you receive, let's say if I receive every 2 values, x, y, this is also another function that takes 2 values at a time, 2 parameters at a time, and returns the x plus y for them. So if you have a list with 1, 2, 3, 4, so automatically if you call this reduce function on this list, let's say if this is a list, on this list if you call the reduce of every x comma y, return x plus y. Okay, so if you simply declare this list of this, it returns the sum of all these elements. It takes every 2 elements at a time. 1, 2 will be taken first and returns 3, and that 3 is considered for the next element. 3, 3 is treated as x, y, and 6, 4 will be treated, and finally value 10 will be given. See? And map method. So if you apply map for every x, I want values to be doubled. Okay? Return 2 star x. See, the output is again another list with the values got doubled, but the number of elements are same. And filter, for every x, so x greater than 2, those only needed for me. So even from filter, the result is another list with lesser number of elements, or at max equal to the number of elements in the input list. These 3 functions or methods are very, very, very important on the collections, and you will use them a lot in Spark. And the next one, so if you, for each is generally, instead of producing a another list as output, so we'll simply, for execution statements, if you want to print ln or something, print ln of each of this x, okay, for every x arrow, just to print ln. So 1, 2, 3, 4. So for every x, you simply can return x as well. But this is not returning you a list. It just executes that. That is the difference between for each and map. So in a map and for each, you are iterating through every element. In all these methods, you are iterating through every element of your collection. But in a map and filter, your output is again another list. And in reduce, it's just one element, it's not a list. And in for each, you'll not get neither a list nor an element. You simply use that for any kind of executions. And so what was the other one? The FlatMap. So you have seen a list with, when you have a 10 elements list and your map is producing again 10 elements list, and filter is producing lesser number elements of list. So FlatMap is exactly similar to your map. Only difference is that the number of elements may not be equal to the number of input list elements. Once you apply FlatMap, your output list, again output is also a list here, output is list, and this list may contain more, or may contain less than or equal to or more than or equal to. It may not be equal to the number of elements. More or less than input list elements. It may match the element count also. It's not guaranteed that how many number of elements that you will get in the output. So technically, I hope you got the differences. So when you will be using these functions, you will see them in our Spark examples. But these four are 5. So for each, FlatMap, map, filter, reduce are very, 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 very frequently used. If you are writing at least a simple Spark program, you will not write without using at least any one of them. You will get to know. So what's the reason behind that? So example of FlatMap. Yep. So I think you might have got the examples for these three, and for each example of FlatMap. So I read for FlatMap, I will give you now. So difference between FlatMap and map. Yeah, that's what I told you till now. So difference between FlatMap and map, the number of elements may not be equivalent to the number of input list elements. Here in map, if you pass 10 elements, the output list will also exactly have 10 elements. And in FlatMap, that is not guaranteed. That's the only difference. Now coming to the example here, let's say I have lines. Okay, so lines is a list. Hadoop is a essential tool for big data. Okay, and Spark runs faster than Hadoop. Okay, so if I declare this lines list of this, how many elements are there in this? Val lines. Okay, so how many elements are there in this? Only 2 elements, right? So this is one string, complete one line, and this is another line. Now I want to split them into different votes. So split by, for every line I want to break that into votes. What I can do is lines dot. Now if I apply map, yeah, I'll show you the difference exactly here. If I apply a map here, for every string str dot split by space. So for every string, I'm using str dot split by space. Now, since I used map and my output list also should have the same number of elements, it returned me. The output is again a list of 2 elements only, but this time the elements are of arrays. The first element is an array, second element is an array. This is an array of strings and this is an array of strings. But if I apply FlatMap here, capital. See, if I apply FlatMap, if you observe the differences between this output and this output, all your values got flattened out, right? So Hadoop is essential tool. There is no restriction that it should maintain only 2 elements. Since in map, it has a restriction that it has to maintain only 2 elements, it maintained in the form of 2 arrays. Now, here there is no restriction on that, the number of elements count is 2. So it produced this many elements. So for the first string, it produced this many elements. Hadoop is essential tool for big data. And for the second string, it produced Spark runs faster than Hadoop. And this difference is very important. Yeah, I think, is it similar to flatten and pig? Yes. There were same words in both the list. There were same words in both the list. Obviously, it will come as a duplicate. It's not a big deal. It's not, you're not maintaining. It will not eliminate the duplicates. All it does is, it applies your anonymous function. It makes sure that all the results of each element operation will be combined, and that combined result will be sent to you. Here the results are not combined. For the first line, this is the result. That result is put inside a one array, and for second line, this is the result, and that is put inside another array. So you got a result of arrays, result by using arrays. So can in remove duplicates. So that's a different scenario. On this list, you process them or you store them as a set and then eliminate the duplicates. That's a different scenario. The next level operation. So FlatMap, flatten will remove duplicates in pig. No, right? Okay, so duplicate, distinct. Okay, you're talking about distinct bag, correct?
Right. So like multiple statements we can run and clean up the duplicates.
Correct.
Right.
Yep. Yeah, here also you can do that. The next level of processing, you can remove the duplicates.
Okay.
Okay. Yeah. So, but these 5 functions or methods are very, very, very important.